So I want to take a look at what kind of interesting input responses I could get if I started with knowing an impulse response for a system. And we're talking about discrete systems. And I want to talk about having 4 different impulse responses. But I want to look at this for an interesting impulse response, which now is actually going to be something that kind of starts off at 0 and then becomes a sine wave all the way through. And this is actually going to be formulated as u to the n sine n pi over 4. So there's actually the frequency in discrete space, omega hat, is pi over 4. And so just kind of step back for a minute and think about what you're going to see here. You would expect that I'm going to start off at 0, everything's still at 0 because nothing's changed. And then at 0, something is going to start getting some activity. And after a number of periods of this sine wave, I'm going to look something like a frequency response. Because after all, if I put in a sine wave, that's what I'm going to get. And of course, I can never put a sine wave in perfectly. So this is the kind of thing I would expect in terms of its dynamics. So let's see what we actually get. And we can take a look at this. And again, the frequency omega hat is pi over 4. One of the things I'm going to show out of all of these is also what is the frequency response at omega hat equals 0 and at pi over 4. And the reason is you're going to start to see some connections to some of those values. And that turns out to be really kind of interesting as we work through the numbers. Start off with the first one. This is a boxcar filter. H1 has got 4 deltas, right? It's 1, 2, 3, 4. And I say, now what would I see if I looked at this response? Well, there is a frequency response to this. If at frequency at omega equals 0, the peak is going to be 4. At pi over 4, it's going to be about 2.62 or so. And so one thing you get is it gets a nice starting input here. And then it doesn't quite get there the first period. But by the time I get to about the 3rd period, I'm pretty close to that number. And so I'm definitely getting that sine wave. Notice the sine wave is coming through. It's almost exactly just a pure sine wave in a sampled form, but that's the number I'm seeing. Now the interesting question is what happens when I go to different ones? Well, let's say I take this one where I just drop it linearly for the 4 terms. What's the biggest thing is the amplitude is going to be smaller. Not surprising, the peak on the frequency response is smaller. But I'm in an interesting spot because now I can actually, where this filter, this sort of structure is known for sort of decreasing things at higher frequency and really keeping things at low frequency, this is going to allow a little bit more of the higher frequency to go through. And so even though I've got a smaller amplitude to start with, I'm actually getting more of the frequency component through. Now notice the change of scales is with 5 to minus 5. This is 2 to 2. We're going to keep 2 to minus 2 all the way down. And what you're going to see here is that, in fact, this is almost as big as the previous. It's a 1.8, but the initial amplitude was significantly smaller. So it's kind of neat to see how these things work out. And it turns out the sine wave is pretty much where you'd expect and is almost converged by the time you get to the final point. Sometimes the convergence, by the way, could even be a little larger. This one's actually a fairly sizable response. This might be argued to be a hair bit smaller. So it's interesting that it's not necessarily goes in a straight line, in a monotonic curve. So then the next thing is you look at another case of different H. These are now 2 IR responses. What you find with both the IR responses is that, in fact, you get a decrease and a decrease over time there. Both of these have different peaks. One is 2, one is 2.5. The one that is a bigger term almost looks like it's going to be a little more, it's going to stretch things out a little bit better. But at pi over 4, the amplitude I get is 1.4. For this one at 0.5, seems to be allowing a little bit more high frequency information. It's almost the same exact value, even though its peak is lower. And that's interesting. Other thing to notice is that this had a delay of 2, so this also has a delay of 2. It's an immediate way, if you were like seeing all of these together and going, which one matches with which, you go, well, this one has a delay of 2, it has a delay, well, for good, right? That already tells you what you're looking for. And so it kind of gives you some ideas, and on top of that, if you looked at this one, you'd go, Right, this is the biggest amplitude. It probably fits with something like this. And you begin to start to look at these pieces, but sort of seeing the plots and seeing the graphs helps immensely to getting a sense of what these various step responses and impulse responses are doing, and even sort of qualitatively doing without having to actually solve it analytically.